Okay, on to the next group. So we're doing constructing truth tables for each compound statement. So these are actually tables. So we're going to start with the simple one. We'll get more complicated. So problem number 47, the compound statement is not P and Q. So the first thing you have to do, just like we did in the previous examples, is figure the number of rows. So the number of rows is just going to be the number of letters, which represent the number of statements. We have two statements, P and Q, and we raise 2 to that power. So 2 is always the base, and then you have 2 to the second power, which is 4. And then we add 1 row for the header column. So that's 5 rows, sorry, this is rows. And then columns, we're going to need 1 for P and 1 for Q, 1 for this, 1 for that, and 1 for that to write out the logic statement. So that's 5. So it's going to be a 5 by 5 table. So we put P, the two statements. Now, even though we have negation of P here, we always just put P and Q here. And then we write out the logic statement. Next, we fill out the columns for the P and the Q. And you start off with, since we have 4 rows, we do half of them trues and half falses. And we do the same thing in the others, but we do a different pattern. So we still have half true and half falses, but we alternate them. True, false, true, false. Okay. Then we go and we look at the logic expression and either copy this or do the opposite. So if we have a negation, we do the opposite of this column. So instead of true, true, false, false, it becomes false, false, true, true. And since we have Q here and we have Q there, we just copy it. And then we use the rules for the AND operator, which says we compare these two columns and we compare the truth values. And the only time an AND statement is true is if they're both true. So that's the case for that row. But all the other ones have at least one false, so the rest of them are false. So 3 out of 4 are false. And that's your answer. Okay, the next one is 50. So pretty much the same kind of thing that we just did, except we switched the negations and made it an OR statement. Again, we have P and Q, so that's 2 raised to the second power, which is 4. Add 1 is 5. And the logic statement needs the same number of rows, columns, 1, 2, 3, and P and Q, the letters. So we need another 5 by 5 table. P, Q, logic statement, P or not Q. Fill these out exactly the same. True, true, false, false, alternate, true, false, true, false. Since we just have P, we copy that. 2 trues, 2 falses. Here we have Q, here we have the negation of Q, so we do the opposite of what we had there. So instead of true, false, we have false, true, false, true. Then we compare these two truth values using this logic statement. It's the OR statement. The OR is false only if they're both false. So this one's false, and the rest are true because there's at least one true. And that's your answer. So, with OR statements, we usually have 3 out of 4 being true and 1 being false. For AND statements, we usually have 3 out of 4 being false and 1 being true. Okay, moving on to 53. So we have a little bit more complication, not that much. Actually, that's 54, so be careful here. So we have not Q, and not P or Q. So again, we have P and Q. So 2 squared plus 1 is 5. So we have 5 rows. Now as far as the number of columns, we have P and Q again. And to do this logic statement, we need a column for the not Q for the AND operator, for not P, the OR operator, and Q. The parentheses are just telling us to do this operation first, and then use the results from that with this operator. So we're going to have 2 columns for P and Q, plus 1, 2, 3, 4, 5. So that's 2 plus 5 is 7. So we need a 5 rows by 7 columns. P, Q, not Q, and not P or Q. First 2 columns, exactly the same. What we're doing here is we're just coming up with all the different possible combinations of trues and falses, and if you use this pattern, you'll do that. True, 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 false, false, true, false, false. So those are the 4 possible combinations of truth values. Okay, now we're going to fill in these 3 columns next. So Q is true, false, so therefore not Q is false, true, true. The negation of P, or not P, is false, false, true, true. Instead of true, true, false, false, that's opposite. And then Q, we just copy Q, which is alternating trues and falses. Okay, the parentheses means that we do this operation first, comparing these 2 columns. It's an OR operator. The only time OR is false is if they're both false. So this is false. All the other 3 are true. And then finally, we do this column, which I haven't done anything with yet, and you compare the truth values between these 2 columns. The result of this operator and just the truth values associated with the negation of Q. The operator is an AND. So we compare these 2. If they're both true, then the result is true. If any one of them is false, the answer is false. So we got false, true, true, false, false, true. The only one that has 2 trues is this one, so that's true. This one has 1 false, so it's false. This one has 1 false, so it's false. And this one has 1 false, so it's false. And that is the answer. And the last one of this grouping is 56. So we're going to, again, still only have 2 statements. But a little bit more complication on the logic statement. 5 rows again. We need 2 rows for P and Q, just like we have here. And then our logic statement, 1, 2, 3, 4, 5, 6, 7. So we need 7 plus the 2 here, that's 9. So what we're going to do is we're going to make a 5 by 5. I have to do this because I can't make a table bigger than a certain amount. Okay. So then I clone this thing and I connect them like that. So there's overlap of 1. That way there's 9 columns. P, Q. Just writing out this logic statement. Okay, first 2 columns. Same, true, true, false, false. true, false, true, false. Negation of P, opposite of that, false, false, true, true. Not Q. There's Q, not Q is false, true, false, true. Not P, we just did that, false, false, true, true. Q, here's Q, just copy it, true, false, true, false. Okay, now we have to do some operating. So we'll do this one, we'll do that one, and then we'll compare the results of those two columns using this operator. So we do what's in this parenthesis first. So this is an AND operator. We're looking for a case where there's two trues. That's true. All the other ones are false, because at least one false. Over here we have the OR operator. OR is false only if they're both false. Both false, so it's false. All the other ones are true. So 3 out of 4 are true. Here 3 out of 4 are false. Then we compare these two truth value columns and put our result here using this operator, which is the OR operator. So OR is true, false, only if they're both false. So let's just compare them. False, true. So let's just look for false, false, and then we'll put true for everything else. So that's false, 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 true, true, true. Okay. So all the rest of them are true with the OR. 3 out of 4 are true. True, false, true, true. Okay, I got the right answer. Okay, so that's it.